Hi everyone. We are going to show how the vector calculus can be used for physics. In the previous video, I said the physics demanded vector calculus, and the vector calculus is kind of math that was advanced by physics. And before getting into those Nabra kind of differentiation of the vector field theory that is used in electromagnetic field theory and beyond, we stick to high school physics, which is Newton mechanics. So-called Newton mechanics is F equals ma, and a is acceleration, F is a force, and m is a mass. But in the vector form, we can express this as this way, or I prefer using vector notation like this. So A and F is vector. Now you can tell the acceleration is always the direction of force. So F equals ma, it doesn't tell you much about direction, but if vector format, it tells you the acceleration happen along the direction of force. This already has a lot of physics meaning in the vector format. And A is, of course, the velocity. Okay, we distinguish velocity in the speed. Speed is typically just scalar v, and when you say velocity, that's a vector v. It has a direction. So we know that acceleration is a derivative function of velocity, right? So if you have a location vector, for example, you have x, y, z, and you take some location, okay, and that is r vector. You take a derivative of r, that's give you velocity, and the velocity derivative gives the acceleration vector. So what you get is second order derivative with respect to time of the location vector gives acceleration vector. Okay, so it's without vector, you went through this in the high school, the physics, right? But you can do exactly same thing as vector. Why can you do that with a vector? Well, if you divide into I, j, k vector component, you are just doing for each direction, and in the Newtons assume the space is uniform and each direction is independent. This any movement along x doesn't affect the movement along the y or z, so it's just a matter of a equals axi plus ay j plus az k, right? And f is same thing. F equals fxi plus fyj plus fzk. Yeah, so you're doing three different directions in 3D world, each direction independently. So take a differentiation with respect to time. So you get f equal ma, So this is a total summary of Newton mechanics. Okay. Now, so why great about using vectors? For example, you did this x direction and the height. You shoot object mass m at the initial vector v0. The v0 is vxi plus vyj, right? Okay. So this go like that. Trajectory, you get trajectory curve. There's a maximum point, maximum height, right? And this trajectory, how do we get the trajectory? The assumption here is you have a constant force mg, that's gravity, right? Gravity constant times mass is gravity. So F equals mg, okay, vector equals what? ma, right? So you have acceleration a equals gravity constant, which is negative gj. We assume this is I and this is a j, right? Okay. Now, if you take a integral, then we get the speed function. So it's going to be g t j plus, don't forget, constant c vector. What is c vector? Well, you have a constant on both sides. C vector is c1i plus c2j. Okay. Now how you determine c1 and c2? The velocity, right? Initial velocity is v0. So when t is 0, v is v0 equals c. So this c is v0. Okay. Now we get the velocity. So let's get the location vector. The location vector is going to be, you take integration again, negative g over 2 t square I, right? Plus c t plus another constant d. And d again decide where initial position is. T is 0, initial position is d. So if you shoot somewhere from here or here, this is a d vector, right? Which wherever the initial location. We assume d is 0, so this is 0 in this case. Okay, so actually this is going to be the trajectory. What do you mean the trajectory? R, X, and Y. Well, in this case, R, X, and H, right? Height. Okay, is given by this. Okay, so what is the highest point? Highest point is V is 0. So this is 0, right? So what you do is C equals G T J, and in this case the C is, we take only Vy, right? So it's going to be Vy equals Gt. So T highest point is given by G. Okay, so how do you interpret this? So every second Vy, this direction's velocity, the speed, is reduced by G. So how many seconds it takes to become 0? So this is the equation, right? And if you put that into the location vector, then Vy G square, I'm looking at this one, plus C Vy G. Okay, so in this case, you can get two information. You shoot from here, and the highest point, this is H max, and you get X max, right? So this is gonna be X max I plus H max J. So you equate this one, and the C is Vxi plus Vyj. So how do you calculate this? There's no, this I component is only this one, this guy. Okay, and J component is going to be this guy, Vy square over G plus this guy minus 2G Vy square. It's going to be G Vy square minus 1 minus let's see, it's going to be Vy square 2G. Okay, so that's going to be highest point. So this one gives you the position, and the V vector gives you the speed of each location. So you can completely analyze this using vector. It's much more convenient. For example, say this R function is x, y, circling around like that, and the speed is omega t. Omega t means in 1 second you go 1 radius, means if this circle is A, you move A along this circle, that's 1 radius. So you take omega t, and cosine is going to be the x component. So you have A plus sine omega t. So this is a movement equation, right? So this movement equation, in order to move like that circular motion, what kind of force is acting? You take a derivative, then V equals A omega minus sine omega t plus cosine omega t. And the acceleration is going to be negative a omega square cosine omega t plus sine omega t. So you compare this acceleration and location vector, and location vector is here like that. Okay, it's a vector from origin to the point on the circle, and acceleration is going to have a negative. That means wherever the location, acceleration is opposite direction. Okay, so what does this tell us? Okay, it tells us that there must be a force acting on this mass in order to make a motion like this circle. What kind of force? Attracted to the origin. And usually that is like a planet circling around the sun. It's a gravity. Okay, so before Newton, Galileo and Copernicus, they made a bunch of data and proved that the planet are going around the sun. Okay, and planet are going around the sun, and they don't know. The Newton, they use a calculus to get acceleration, and his assumption, force equals ma, Newton said there must be a gravity acting on the planet in order to circle around gravity center, which is the sun. Okay, so this is a discovery of gravity. So this negative tells you that the circular motion, there is always force acting toward the center. So using vector calculus, you can easily tell. And Newton didn't use vector calculus. He used the regular algebra and came up with this acceleration pointing toward the sun. Nowadays, scientists found several large stars circling around in the middle of galaxy. And why circling around? There must be something, gravity center. And the telescope doesn't show what's in there because it's a black hole. But from the movement of this star, they calculated the size of black hole. The huge black hole existing in the middle of galaxy. And that's, using this equation, you can easily predict the existence of black hole. So Newton discovered the existence of gravity, and nowadays they use that same equation to predict the existence of black hole in the center of galaxy, because many stars going around something, and there must be a huge force acting on those stars. They are not planets, they are stars, like a sun going around. So black holes' total mass is huge, and it's attracting them in order to make them circular motion. Okay, so if you calculate this the gravity is this, right? So it's going to be m. The a is cancelled out, and cos and sine. Okay, so what is this term? M. This is like m oh, forgot the a. M, the, you know, omega is AV, right? The speed along this circular motion divided by A is going to give omega. So it's going to be V square over A. And this is a force acting on circular motion when you pull by string and let it go around. This force is this string pull this much because this one produces this much force. Okay, so in order to you swing these things by string, the mass m, this produces the force this much and counteracting force. This is not the real force. You don't need this force. Existence of this force is going to let this go circular, but there is force as if there is this much, right? And that's why you cut the string, then it's fly off with this much force. Then flying projectile based on initial force of this. Okay, so that's a fun of physics to figure out those stuff. Now I hope you understand how good vector calculus is to do the high school math. It's make everything so simple using vectors, vector function and vector derivative function. If you like this video, please subscribe and wait for the new videos. More fun's coming. Okay.